Good evening, everyone. It is 7:30 p.m. Eastern Standard Time, 8:30 p.m. Eastern Daylight Time. Welcome to the Leitner Observatory and Planetarium Tuesday night, public night live stream. Beautiful night here. It's a beautiful day here in New Haven, and it's very clear tonight, at least so far. And bugs are flying around out on the observing deck. Here we're seeing a live view of the Leitner Observatory deck, looking out over Farnham Gardens towards the Klein Bio Tower and out over East Rock and East Haven neighborhoods. I'm Michael Faison. I'm the director of the Leitner Observatory and Planetarium, and I teach here at Yale in the astronomy department. Thanks, everyone. Looks like there are a few people here on the live stream. Thanks, everyone, for tuning in. Tuesday night, the observatory opens up to the public, but we've been closed for about a year. It's been a little more than a year that we've been closed. So I've been doing these live streams on some Tuesday nights to talk about what's up in the sky and to show live views through our telescopes. And it's almost warm enough to go out for me to go outside and do stuff on the observing deck or in the observatory domes. I would actually like to do some public night live streams from the refractor, from the Reed telescope refractor, which I went in there the other day and I realized I hadn't been in there in not 6-7 months. We have a historic 8-inch refractor here at the observatory, which is a lot of fun to use. So I'd like to actually do some observing from out there. Let's see, the Leitner Observatory weather station is saying it's about 55 degrees outside right now. So again, welcome everyone. This is live. I'm watching the YouTube live chat, and if anyone has any questions about astronomy or what's up in the sky or things we want to look at with our telescopes, let me know. Type it in the chat, and as soon as I notice it, I'll try to answer your questions. In this live view of the observing deck, you can see our 12-inch reflecting telescope, which I've been using a lot for these live streams and also for remote student labs. So we're closed to everyone. I'm literally the only person who works up here most of the time. And so we haven't had any classes, haven't had any public events at the observatory for quite a while. So I have this 12-inch reflecting telescope set up on a computerized mount on the deck. And there's a video camera on the main focus of the telescope, and I can show you what the camera is seeing in real time. So I'll do that in a few minutes. Before that, I'll just talk a little bit about what's up in the sky this week and a little bit about astronomy news, and then we'll go point the telescope. I'm actually very interested in taking some pictures of an asteroid tonight, as well as some galaxies. So we're getting into spring, real spring. Happy April, everyone. We're getting into real spring when the constellations of Leo and Virgo are higher in the sky at sunset. And those areas are rich with galaxies, the Virgo cluster, the Coma cluster. And then there are quite a few beautiful isolated galaxies. Quite a few nice galaxies over in the direction of the Big Dipper. And the Big Dipper is high in the northeast at sunset this time of year. Really don't have any planets up, but let me just show you what's up in the sky. So let me bring up a browser here. So yeah, nice clear night tonight. Looks like it's going to be clear until about 2 a.m. Yeah, and it's about 55, 56 here at the observatory at 355 Prospect Street. Let's take a quick look at the sky map again. So this is skymaps.com. This is the website I recommend to get a monthly sky chart and calendar. It's easy to use. It's free. It's nice to print out on double-sided paper and take outside with a red flashlight or with your phone and a pair of binoculars and find things in the sky. So let's take a look at the map for April here. So we'll zoom in a little bit. And so this is what the sky looks like about 10 p.m. In early April, so about now. At the end of April, of course, the Earth will have orbited 1/12 of the way around in its orbit relative to the start of April. And so the sun will have moved a little bit relative to the background stars. So which stars you see at sunset to the west or overhead at sunset, or in the east at sunset, will shift by about 1/12 of the sky. So the constellations are seasonal, and that's why you need a star map or a planisphere or an app to figure out what stars and constellations are up in a particular time. So let's see. Let's find out where the ecliptic is. The ecliptic is the plane of the solar system, and let's look for planets. And really the only naked eye planet that's out in April is Mars. And it's right over here between the stars and the horns of the bull, kind of straight up from Orion. Mars moves a little bit over the course of a month, and I'll show you where it is in the sky tonight. But it's gotten quite faint and small. So you may not even notice it. It won't stand out to you. The star Aldebaran is going to be brighter. The stars in Auriga are going to be brighter. You can find Mars if you know where to look for it. It's visible to the naked eye, but it's a dim little dot. It's not nearly as bright and big as it was last October when it was very close to the Earth in its orbit. We're also losing the winter hexagon. So if you start with Orion and take the belt stars, go down to the left from the belt stars are kind of hugging the horizon at the moment. There's the bright star Sirius, the brightest star in the sky. And you can go up from there to Procyon, Pollux and Castor, Capella, Aldebaran, and we've lost Rigel, the foot of Orion there. So I think as of the middle to the end of April, we can say goodbye to Orion. It's going to be gone until midsummer when you can get up early in the morning and see it, or until the winter when you can see it at sunset. The bright stars that are up in the spring include the star Regulus, the bright star in Leo the Lion. Leo is almost due south at 10 p.m., and I'll show you where it is in the sky in a minute. The bright star Spica. Spica and Regulus are close to the ecliptic, so they're kind of like pseudo-planets. They're not planets, obviously. They don't move around relative to the other stars. But they're bright stars along the ecliptic, so if you're looking for Jupiter or Saturn or Mars, they're going to be kind of along that line along with those two bright stars. Then you have the Big Dipper, which is not quite overhead as seen from New Haven. It's a little bit north of due overhead. The overhead point is that cross right there. But it's easy to find the Big Dipper, 7 bright stars that are part of the bigger constellation of Ursa Major. Something I was pointing out to my astronomy class last week when we were talking about the Big Dipper and the Big Bear. The 7 stars in the Big Dipper are easy to find, and there's some interesting bright galaxies. Maybe we'll look at some of these. M94, M51, M64. Those are all interesting objects to look at through a telescope. M81. Let's go look at M81 tonight. I want to go look at that through the telescope if it's still clear. But those 7 bright stars are easy to see, but you can also see with the naked eye, if the sky is dark where you are, all of the other stars in Ursa Major. These are all naked eye stars. And they're these lovely 3 pairs of stars. So 6 stars, this pair, this pair, this pair. And they make up the claws, or the paws of Ursa Major, the Big Bear. This is kind of his nose, like so. That's his back, that's his tail. Bears don't have tails that long, but there's a story. There are various star lore stories about how the bear got a tail that was so long. So those 3 pairs of stars, they're about the same brightness. They're spaced out equally. In Arabic star lore, they're called the 3 leaps of the gazelle. So there's a story about a gazelle leaping to get away from Leo the lion over here. Joop, joop, joop. And they're lovely to see if you can go someplace where the sky is dark. Then coming up in the east is the bright star Arcturus, the brightest star in the constellation Boötes the herdsman. And then next over would be Corona Borealis, the northern crown, which really does look like a crown, or at least a crescent. There are a lot of interesting stars in Corona Borealis. Maybe I'll talk about that if I have time. And then coming up in the southeast is Hercules, the hero, with the beautiful star cluster M13. And then Vega, the first star to appear in the summer triangle, and the brightest star, is coming up in the northeast later on in the evening. In terms of events this month, there's nothing really spectacular happening. Let's see, tonight is the 6th, so we have moon near Saturn in the morning sky. So the phase of the moon right now is a waning crescent moon. So on the 4th was last quarter moon. That's when it's half illuminated on the side towards the sun, always the side towards the sun, and you have to find it in the morning sky. I've seen it in the daytime in the morning this past week or so. And then about a week later, you have new moon. So on the 12th, what day is that? That would be next Monday, I think, right? Yeah. So then we have a new moon. So then we'll start to see a crescent moon in the evening sky next week. So then we have moon near Mars on the 17th, but again, Mars is very dim. It's not really going to be remarkable. This is interesting, though, occultation visible from Southeast Asia. So an occultation is when the moon blocks an object, often a planet, sometimes a bright star like Regulus or Spica, or there are a few other candidates. So that's interesting, but that's only visible from Southeast Asia, so I won't be able to see it. Let's see, Mercury is in conjunction with the sun, that's fine. Yeah, Lyrid meteor shower, I talked about that last time. We'll have a first quarter moon, so it could be interesting to view. I think if it's clear, I'll probably go out and look to see after midnight, look to see if there are any meteors that night on the 22nd. If you have a pair of binoculars, it's nice to look for some of these celestial objects on the back of the star chart. So some of these star clusters like M44, the Beehive cluster, or M13, the Great Cluster in Hercules. So they're described here on the back of the chart, and then they're labeled here on the front of the chart. And if you have dark skies, you should have no trouble finding any of these with 10 by 50 or even 7 by 35 binoculars. Okay, so let's see if any astronomy news I wanted to mention. I'm still fascinated with the Perseverance mission and the upcoming flight of the Ingenuity helicopter. So NASA's been putting out, and JPL have been putting out several press releases and some PR and some news items about this coming up. I thought this was interesting. Mars helicopter survives first cold Martian night on its own. So here's the helicopter right here. It's been deployed by, see if I can get out of the way a little bit. It's been deployed by Perseverance rover, by the rover. And so it's being tested out, and the camera has been tested. I think actually it's taken already its first images. Yeah, here we go. So they know the camera is working on the helicopter, which is important. And so it looks like the first flight is going to happen very soon. I think potentially on, there it is being deployed by the rover. Amazing. So it's going to have its first flight, completely autonomous flight. I think it flies for about 2 minutes or so before it needs to land and charge up its batteries. It has solar panels on it so that it can charge once it lands on the surface, as long as it's not too dusty or cloudy on Mars. And so it's coming up, first flight possibly by April 11th. So I am very much looking forward to the news of this. There's really an amazing video here on the Perseverance homepage that shows what artist's impression of what is going to. Oh, here we go. First flight no earlier than April 11th, right? So you can watch this and find out about this. Now, there's all sorts of interesting things about how they managed to save weight on the Ingenuity helicopter drone, because yes, it's true that Martian gravity is about 1/3 that of the Earth, so that's good. But the Martian atmosphere is very thin compared to the Earth, about 1% of the density of the atmosphere on the Earth. So the helicopter blades are about 1 meter across. They're pretty big, and there are 2 of them. Now, if they had to save weight, why 2 helicopter blades? That seems like a waste, right? Isn't 1 helicopter blade sufficient? And no, this is a great opportunity to talk about the physics of helicopters. If you have a motor that's making a propeller spin, there's going to be an equal and opposite torque that would twist the helicopter around. So helicopters on the Earth will always have maybe a tail rotor or counter-rotating blades. Like on the Chinooks, there's a blade at the front and a blade at the back, and they spin in opposite directions. If you've ever played around with a quadcopter drone, There are 4 blades, and they have to spin in opposite directions. So the 2 in the front are spinning opposite the 2 in the back. And in fact, that's one way you can rotate the helicopter. The tail rotor on the helicopter can push one way or the other with enough force to counteract the torque from the engine. And then if you speed up or slow down the tail rotor, you can rotate. Maybe there's someone from Sikorsky on the on the live stream who can correct me if I'm saying anything wrong. You can make the helicopter rotate. But then if you have 2 blades, like on a Chinook, or like the 2 blades on the Ingenuity rover, you can control the torque of each blade and use that to rotate the craft. And that's also how a drone, a quadcopter drone, works. By changing the torque, you can make the thing yaw. You can make it rotate around that axis. Anyway, I'm looking forward to April 11th. I hope things go well. I hope it doesn't crash. I hope we get some amazing aerial footage of the Perseverance rover. This is how you know it's coming from, a helicopter on Mars. If you see human artifacts there on the surface. So can't wait for that. The other astronomy news that I saw that I might mention in the live stream is that this is International Dark Sky Week. So this is something that happens every year, and there's usually one day where you have Earth Hour, where people are encouraged to turn off any sources of light pollution for an hour to bring awareness to light pollution. So, I didn't think that much about light pollution for a long time, partly because when you're doing either professional observing, you're using telescopes that are far away from cities, up on mountaintops. And when you're doing teaching observing, a lot of the projects that you do, it doesn't matter that much that the sky is bright because you're using digital cameras and you can subtract off the light pollution and so forth. But I've been doing more stargazing lately, and I've been doing more astrophotography with a small camera lately. And I've been noticing the light pollution a lot more. And I've been keeping track of some of these satellite internet constellations that are going up, of tens of thousands of low Earth orbiting satellites. So on the one hand, I think it's great that everywhere in the world potentially can get low latency internet. Everywhere should get cheap, good internet. But I do worry about the light pollution that's going to come from this swarm of satellites everywhere in the sky. And it's going to be another step of distancing us from nature, from the natural universe and the lights of the universe. Also, we've had a lot of bright LED lights go up in New Haven, and including around the observatory. If I go back to the deck cam here, a lot of the street lights up here are now these super bright white LED lights that are not well shielded. And I have noticed qualitatively that the light pollution at the Leitner Observatory has gone up over time. Now, we have archived images from our telescope going back to 2010, 2009. So it'd be an interesting project. I should get a student to work on this, to go back and look at our old images every year and measure not the stars in the images, but the brightness of the sky in the images, and quantify and see how much light pollution has changed up here. Anyway, I do support the International Dark Sky Association. I do support movements to bring more awareness to light pollution. I don't think everyone everywhere has to have super dark skies. I think that's impractical, right? But I think there should be dark sky reservations and kind of dark sky minimums. If you can't see the Milky Way from where you are, you should at least be able to see 100 stars and see the bright, important constellations like Orion and the Big Dipper, wherever you are. And there should definitely be dark sky preservation sites, places you can go and experience the night sky the way we've experienced it for 1 million years without artificial lights. And those satellites are really going to do those places in. You can get away from city lights still fairly easily. But those satellites are really going to spoil it for us. Another resource I thought it'd be good to talk about would be the light pollution map. So if you were interested in finding a place where the sky is dark, this is something people often ask me. What's the closest place to go to look at the sky where the sky is really dark? So I recommend this website called lightpollutionmap.info. So let me just paste this can just maybe paste this part into the chat. So if anyone wants to take a look at this, you can open that up. So this is a website that keeps track of satellite measurements of the Earth itself and keeps track of the brightness of the sky in these different places. So not surprising, the Northeast has a lot of light pollution, right? A lot of people, a lot of light pollution. If you look at Connecticut, down here in New Haven, if I were to, there are a couple of different atlases you can use. There's a, there are some that are more up to date, so they're going to show more light pollution. I like to use the World Atlas 2015 because they have this classification called the Bortle number, or the Bortle class. So class 6. So this is something that astronomers know about, and it's kind of a useful, the lower the number, the better. It's kind of a useful tracking device for how dark is the sky going to be when you go. You hear amateur astronomers and astrophotographers talk about this. Usually astrophotographers want to go to a place where the Bortle number is 4 or less. So, the Leitner Observatory is right here. So that's we're at Bortle 7, not very good. I live up here in Hamden, kind of in this area, and it's still class 6 there, so not that great. I was looking for some places where my family could go camping this summer, especially for some meteor showers and some astrophotography projects that I want to do. And so I was looking at a campsite up here, and this is class 4, so that's pretty good. And we're going to do some camping up in Vermont this summer as well. So you get up into Vermont, and especially up in the Green Mountains, class 3, that's pretty good. Of course, if you want really dark skies on the East Coast, it's tough. You can go up deep into the Adirondacks, and it's dark. There's a state park over here in Pennsylvania. I probably can't find it easily on this map, but it's somewhere in here. It's called Cherry Springs State Park. Pennsylvania State Park, there's camping there. And it's considered to be one of the darkest public places you can go on the East Coast. So a lot of amateur astronomers and astrophotographers go to that state park from the East Coast. Go to that state park over the summer at some point. There's even a star party. I forget, it's during the new moon in July. So the week of the new moon in July, whenever that happens, there's a big star party. Lots of people come to the state park together and enjoy the dark skies. Now, of course, if you go out west, it's much easier, right? So if you were to go out to, say, I used to live in New Mexico in Socorro. So here's Socorro right there. So a lot of city lights in Socorro, but you don't have to go that far out of town to see really, really dark skies. And I was going out to observe at the Very Large Array, which is that sort of triangular shaped pattern right there. And when you're out at the VLA and looking up, it's really dark. Bortle class 1. That's basically as dark as it gets. You have to go up into space to see darker skies. And there are quite a few observatories, of course, professional observatories and amateur observatories. One of the observatories we often use for remote observing for teaching and student research is in southern New Mexico in, let's see, there's Truth or Consequences, there's White Sands, there's Alamogordo. So there's a site up here in the mountains near a place called Mayhill. And it's actually not as dark as you might think because of the Air Force Base over here, sort of up in the mountains up here, class 2. It's pretty dark. It's dark enough. And actually, Yale has a research telescope up there, the Dragonfly telescope. I should bring someone onto the live stream to talk about the Dragonfly telescope at some point. It's a unique telescope that it was built by Yale, belongs to Yale. And so to talk about that sometime. Anyway, so this website is a great resource if you're traveling or you want to find someplace. You know, if you are in New Haven or in southern Connecticut and you're thinking, where can I go? The Northwest is really going to be the best place to go, sort of up in this area where the AT cuts through Connecticut. It's going to be the best. That's where you're going to see the darkest skies. Okay, well, let's do some observing from light-polluted New Haven, Connecticut. So I'm going to switch over to the telescope control. So there's the telescope right now, and you can see it's pointed at something that's east of overhead. There's the camera right there in the back, and the telescope's kind of pointing off at an angle like so. So let's go to the control computer. And here is an image from our all-sky camera. I took this just before I started the stream. Let me take another one. So we'll take about a 10-second exposure here. Take the photo? No. Take the photo. Okay, there we go. There we go. Oh, wow, that's really bright. I mean, it's really dark. The stars are bright, the sky is dark. This is a really good night. No moon is out. Yes, there is light pollution, but I don't know, it didn't seem that bad when I was looking out there. There's an airplane or a satellite, could be a satellite flying up from the southeast. I think that's probably an airplane. And wow, so many stars. I see the 3 leaps of the gazelle right there. There's 1 leap, 2 leaps, 3 leaps. I can't see that with my naked eye. Now, we did take, what, a 5-second exposure with this camera, but this is actually a pretty dark sky. There's Mars right there. So there's the face of Taurus the Bull. There's the planet Mars. There's the constellation of Gemini. And there's the constellation of Leo the Lion. I have the telescope pointed right now at Regulus, this bright star in Leo. There's Orion getting low in the southeast, so we're losing it for the summer. I can see the Big Dipper up here, and those galaxies I want to look at are kind of right in there. There's the North Star, that's Polaris. Galaxies I'm interested in are kind of right in there. So there is the bright star Arcturus coming up over the dome. Yeah, so it's a nice, clear, dark night. Wish we could all get together in person and look through telescopes outside, but this is the next best thing. So if I go to the telescope control computer, you see there I am pointing at Regulus. And if I just take a quick image, let's see here. Let's make sure we're still pointed at Regulus and see if it's, yeah, there's Regulus. It's in focus. Last week I was having trouble with the focus on this telescope, so I didn't get very good images. There's Regulus and the star right next to it. So what should we go look at? Although I'm tempted to show something really impressive to start with, I'm also tempted to just go take a picture of that asteroid right there. I'm really interested in that asteroid Vesta. I've been tracking it for the last month and a half. Let me compromise, and we'll swing over and take a picture of a galaxy, and then we'll take a picture of Vesta, and then I actually want to go up and try to get the M81 galaxy, because I think it'll be quite nice. Here's a galaxy up here. This is NGC 2903. And even though it's an NGC galaxy as opposed to a Messier galaxy, it's quite bright, it's quite interesting. It's a barred spiral galaxy, if I remember correctly. So I'm going to move the telescope. I'm going to command the telescope to move over there. And we see the telescope and the live view tilt to the right and tilt up. All right, looks good. All right, so let me make the sky darker here and zoom in on that part of the sky. Lots and lots of galaxies. Every one of those every one of those red ovals is a galaxy. Now there's also, it's a little misleading, there's also a lot of red dots here which are asteroids. I uploaded an asteroid database earlier tonight, and so there's a lot of very faint asteroids that we wouldn't be able to see. So I need to actually delete those. You see how they're moving, those arrows, those gray arrows are all showing how they're moving. All right, but I'm interested in taking a picture of that galaxy there. So let's go over here and we're going to clean away the images of Regulus, and we're going to take a longer exposure. We're going to do, cooling. We'll increase the amplification factor here. We'll do 30-second exposures, which will then get combined. So we'll see the image get brighter and brighter the longer that we watch. And here we go. We're taking a picture of this spiral galaxy NGC 2903 near the face of Leo the Lion. Let's see how it goes. Didn't like that last image. That's fine. Okay, there we go. So there's the image. That's the first image. So this will look better and better. Subtract off some sky background. That looks pretty good for a 30-second exposure. And it doesn't like that last image, so I might have to, let's see if it'll combine this one. So I'm going to clear that. Yeah. And start again. That's the single image. It'd be nice to see a supernova in this galaxy tonight while I'm looking at it. Not impossible. You get about one supernova per galaxy per 100 years. So why not tonight? Could be any night in 100 years that a supernova goes off. Why not tonight? Make it a little bit brighter and actually improve the color a little bit too. I'd really like to get several images combined. Okay, there we go. Yeah, it looks pretty good. I don't see any supernovae, but to really check, what I'd have to do is go look at archived images and see see if there are any new stars there. But yeah, you can see there's spiral arms are there. Even with the light pollution, we can see them. These are stars in the Milky Way that you're seeing in the foreground here. There are also a few kind of noisy pixels. There are a couple of places where the noise is a little bit off. I mean, there's a little bit of camera noise. You can't do anything about that. But yeah, that looks pretty good. I think you'll be more impressed with the M81 galaxy. So here's what I want to do. I'm going to clear this set. Okay, and go to the Vesta asteroid. All right, which is right over here. There it is. Let's move over to that. And I'm going to take a couple of images and save them because I'm going to analyze them later. I've been tracking the position of this asteroid for a few months, and I'm going to be making actually an instructional video over on the Yale Summer Astronomy, our astronomy program channel. I'll put a link to it in the comments for this. In the description for this video, so you can find it later if you're looking for it. But I'm going to be doing some instructional videos on how to solve for orbits, track asteroids, track planets, track satellites. So project that I've been working on. Okay, so let me take some pictures here. And I'm just going to set this up. I don't need quite that long of an exposure. Hey, so there it is. Now let me adjust the, there it is. Now exactly which of, so there are background stars and then there's the asteroid Vesta. So which one is the, turn the cooler on, which one is the asteroid and which one is not? We can zoom in here and get an idea. So there you see the star pattern. So there's that yellowish star right there, there's the star, then there's that triple of stars right there. So I think that, yeah, the image is inverted right now. Yes. So if I actually invert this image for you, there we go. Then the one on the bottom is the asteroid, and then the one on top is a star. So that's the asteroid right there. Boy, it's bright, isn't it? It's surprisingly bright. Is it over bright? No, I think it's fine. It's surprisingly bright, and it's the brightest asteroid actually in the asteroid belt. This is a main belt asteroid, about 300 kilometers across. Very reflective, so it looks quite bright. And in fact, when it's close to the Earth, you can see it with the naked eye. It is potentially a naked eye minor planet. Now, if we were to take a bunch of images and combine them, it looks like I don't have quite enough stars here to stack images. We would see it move. Now, it moves quite slowly compared to near-Earth asteroids. It'd be better to watch it over several days and watch it move. But I'm going to go ahead and save this image. Okay, so that's saved. And later on, I'm going to do some analysis on its position relative to the stars. Yeah, M51 is a nice face-on spiral and relatively bright. Should we go to M51 next? I kind of want to do M81. Let's zoom out. M51 is over in this part of the sky. Why don't we do both? Why don't we go to M51 and then M81, and we'll see how they look. So I'll take that suggestion and go to M51. So Messier number 51, face-on spiral galaxy, actually a pair of galaxies. Let's find it. Okay, there it is over there by the handle of the Big Dipper. So we'll start moving the telescope. And now you're going to see actually the telescope move quite a bit. It's going to, it's moving to the left a little bit, but then also it's going to turn and kind of face the direction of the observatory deck, which is a little bit of a problem now that I think about it, because the observatory deck camera has LED lights on it, infrared LED lights, and the camera is sensitive to infrared light. So we'll see if we get a lot of scattered light. Actually, it doesn't look like we're going to get a lot of scattered light into the telescope there. Now you can see at this angle, you can see the corrector plate, the front lens right here, and you can see the secondary mirror right there. So the way this reflecting telescope is designed, the light goes in the front, goes all the way to the back, gets focused by the primary mirror, which is a 12-inch diameter mirror, goes back up to the front, bounces off of this second mirror right here, and then goes back out through a hole in the primary mirror to get detected by the camera. Okay, let's see what we've got. We're going to switch back to the control computer. All right, there we are, pointed over there. Hey, there it is. Might want to nudge the telescope over a little bit. So I think I want to move the telescope this way. Let's see if that improves. Let's going on, and we'll see if we have enough stars here to stack images. 10-second exposure. I'll also want to do, yeah, that's good centering. So we're going to up the gain and we're going to up the exposure time. Okay. Okay, so we'll see if this allows us to combine images here. All right. This first image isn't that great. Those fuzzy lights that you're seeing there, so you see stars in the Milky Way all over the image, and there's the fuzzy nucleus of the smaller background galaxy, and there is the fuzzy nucleus of the spiral galaxy. So I think it'll take, stack finished. I think we're good. Single frame, stacked. Okay. So yes, this image is going to gradually get better as time passes and as we get more images combined. And I think after a few minutes, we'll see those spiral arms in the whirlpool a little bit more clearly. Let's see if, yeah, let's see what the all-sky camera is showing right now. So I'll take another image and you'll see everything shift a little bit to the right because of course the Earth is turning. So if you've just tuned in recently, we're doing live observing at the Leitner Observatory, looking at some galaxies and one asteroid live through the 12-inch telescope that's out on the observing deck. I just got a live all-sky image, and there are a few clouds here and there. There are a few clouds over here in the northeast, east-northeast. But overhead, it's really beautiful. The sky is remarkably dark for New Haven. Let me actually even take a longer exposure. I think we'll see even fainter stars. You can really see the Great Bear, Ursa Major. There's the tail, there's his back, there's his nose, there's his front leg, and then one of his back legs and the other back leg. So it really does match what you see in the star chart. Let me show the star chart again. Yeah, here's the star chart. So that's what we're looking at right now in the all-sky image. Yeah, this is a better image. Let me adjust the brightness and contrast just a little bit. Okay, now now I'm starting to see spots on the cover, on the lens cover. So I should clean that off with some Windex. There is a little bit of ambient light out there. And so there's a couple of places where light's reflecting off of the plastic dome that covers the all-sky camera. This is a great image, though. This looks really good. Really see some of the fainter stars in the zodiac, and there's the constellation of Cancer right there. There's the M44 star cluster right there. So yeah, really nice. All right, let's see how our galaxy is doing. Still only combine one image. I don't think I have enough stars in this image to really, this was the last single frame. I don't have quite enough stars in this image to really get a good stack, which surprises me. Let me try one more time. Yes. Okay, there we go. Seven seconds. The countdown for the exposure is down here in the lower right. right, so that's one image, it's aligning. Okay, there we go. So that one's a little better. Bit noisy though. That's okay. I've seen better, but you can definitely see the spiral arms there, and you can see the two nuclei of the galaxies. Not quite enough stars to really match and combine here, so that's a little bit disappointing. I'm going to go take a look at M81, and then maybe I'll sign off for tonight. So galaxy night tonight, and actually pretty much every clear week, every clear night this month and next, I'm going to be interested in looking at some galaxies with the telescope. And maybe also some stars, double stars, and some star clusters with the refractor, with the 8-inch refractor outside, when it's warm enough for me to sit out there for an hour and a half. Okay, so I am actually going to save this image, and then I'm going to command the telescope to move to M81. So telescope, let's find M81. Is this real astronomy when you tell the computer to move the telescope for you? Okay, here we go. We're working on a remote automated telescope for teaching purposes. I've got the prototype over in the corner of the staff office here. And I'm going to be setting it up in my backyard as a test. It's got to do everything on its own, so find stars on its own and take calibration images on its own and so forth. So it's kind of an interesting project. Okay, so we're going to be looking at a part of the sky very close to the North Pole. And if I zoom in, you can see what that galaxy looks like. Classic SB spiral with nice blue spiral arms. Our image isn't going to look this good, but I think it'll be recognizable. It'll look like this image. So let's clear this image. And I think 30 seconds is going to be good. I probably will need to nudge the telescope over a little bit. We're pointing, oh, look, you can see where we're pointing here. Not quite straight up, a little bit north of straight up. I won't be able to track at that angle for very long, because as the telescope tracks the sky, the camera is going to get closer to the pier, and the computer knows that, and we'll stop the tracking. Okay, so let's start taking images. Hey, so there's the first image. Looks good. My focus may have gone out a little bit. I see a lot of stars. Definitely see the galaxy. 100 billion stars there all in one place, located about 100 million light years away. Actually, not quite that far for M81. What's the distance for M81? More like 50 million light years or so for M81. Let's see. So we've combined two images there. Let me do some adjustments. So M81 is part of a group, a galaxy group, with the nearby irregular galaxy called M82. Okay. All right, we'll let that expose for a couple of minutes. I'll talk a little bit about the galaxy. Beautiful spiral galaxy with two very symmetric spiral arms, relatively big central bulge full of old stars. It's quite probable, it's quite likely that this galaxy has been interacting gravitationally, pulling on other galaxies in the nearby group. And that has led to a burst of star formation that's led to this very symmetric look to the spiral arms. I'd like to get some nice blue color in the spiral arms, but they're quite a bit fainter than the central part of the galaxy, so it's tough. It's tough to get that to show up. I would probably need to go in and futz with the white balance in the image to make that look really good. Getting a little bit of a dust lane back there. Now we've got 4 images combined, effectively 2 minutes of exposure. Yeah, so this image is looking a little bit easier to calibrate and combine. So yeah, that looks really nice. Again, it would be great if there were a supernova tonight in this galaxy. There was a supernova in this galaxy sort of right in here, a star that exploded in this distant galaxy that was seen from Earth in 1993, known as supernova 1993J. And I was in college when this happened. It was the winter of 1993. And I was one of the students who used my college observatory. I went to Oberlin College and we had a nice observatory there. And I love to go up there and work on clear evenings. And heard about this supernova, took some images of it, studied how the light decayed over time. And that's actually a student project that we sometimes work on in the summers with our high school research students. Not this summer, but hopefully, almost certainly, definitely, next summer we'll have high school students doing supernova studies for us again, using the telescopes here at the Leitner Observatory. Yeah, these images are looking great. We're up to a 3-minute exposure. I think I'll take this up to maybe about 5 minutes and then save it. Something you can start to see in this image is some artifacts from the camera. There's some dark areas up here and dark areas up here. So there are ways that I can improve that. I can calibrate that out and get a nicer image. And in fact, I might want to make it a little bit darker. Yeah. Yeah, this is great. This is probably one of the best images we've made of M81 in 5 minutes from the Leitner Observatory. It's pretty dark over in that part of the sky. The focus is okay. I think it's actually fine for this telescope. Yeah. Oh, yeah. Cherry Springs Star Party. Is there another Star Party, the same location in early fall? I don't know. Black Forest? Yeah, I don't know. I don't know of any. I only know of the one at Cherry Springs. And I've never been there. I'd like to go. I'm usually busy in June and July. Yeah, I'm not really a Star Party guy. I'm not very social. I like doing my own thing. But I've kind of changed as I get older. I've gotten more interested in like old guy astronomy. And I've gotten more interested in astrophotography and maybe into star parties and so forth. Yeah, it looks pretty good for like 5 minutes from the middle of a city with a 12-inch telescope. So yeah, I think for people watching, this is a really nice image of M81 taken fairly quickly without a lot of effort. I mean, the effort has gone into setting up the mount and the telescope. If you're an amateur astronomer and you want to take pictures like this, it does take some training and some investment and so forth. Although it's not as hard as you think. If you start off with just a digital camera and a tracker, and then invest in a lens, you can take some really amazing images. A lot of the images that I've been taking of Leo and Vesta have been taken using a digital camera and a star tracker. And so I've been interested in going around and going to dark places with my star tracker and my cheap telescope. I bought a $200 telescope last summer at the start of the pandemic quarantine. And very quickly it got hard to get telescopes. It got hard to get telescopes. There was suddenly a shortage. A lot of these telescopes are made in China, especially the lower end telescopes. And there was a slump in shipping, manufacturing in China and shipping from China. Kind of like computer chips, it was suddenly difficult to get telescopes. Oh, Black Forest Star Party is at Cherry Springs in the fall. Oh, that's good to know. Maybe I could actually make it to that. That would be interesting. It's not that far from here. Cherry Springs is not a long drive from New Haven if you're going out for a camping trip. Oh, I don't qualify as an old guy astronomer. I'm getting there. Lord willing, I'll make it to be an old guy astronomer soon. Okay, well, I'm going to save this image, and I'm pretty happy with it. Yeah, I'll post the when I do the calibration and so forth, I'll post the final image in the description for the video there. And if anyone has any questions about galaxies or astrophotography, if you're interested in that, or any of the astronomy that we do at the Leitner Observatory, I am going to be posting some updates on upcoming events with a live stream. I'm going to be doing some demos of beginner telescopes, and I'm going to do some observing in the refractor with the refractor. And I think we're going to have one more guest speaker coming to talk about research in early May. We're going to have someone from Yale Astronomy who does research on Planet 9. And this is not, Art Bell style pseudoscience. What was the name of the killer planet near Nibiru or there was one I can't remember now. My conspiracy theories about hidden planets it's escaping me. Anyway, so we're going to have someone who does actual research looking for potentially large planets in the outer solar system in May, and a few other events. So I'll be posting information about that on the Leitner Observatory website. So the Leitner Observatory website, if you don't know, of course, you can obviously Google Leitner Observatory, Leitner. But our main website is leitnerobservatory.el.edu. And again, my name is Michael Faison. And if anyone would like to email me, my email is michael.faison, Faison, at yale.edu. And happy to answer emails about anything astronomy related or Yale related or Leitner Observatory related. And this has been a fun session. We looked at Regulus, NGC 2903, the asteroid Vesta, the galaxy M51, although that image wasn't very good. And then we got a nice image here of M81. All right, let me save this image before I forget. All right, save. Okay, and I'll wish everyone clear skies and good night, and I'll see you on a live stream in the near future, maybe next Tuesday. All right, bye everyone.